Good morning, students. So today I am going to discuss about this topic perfectly inelastic collision in one dimension. This topic is from this chapter work, energy and power. So in this topic I am going to prove that there is a loss of kinetic energy during one dimensional inelastic collision if collision is perfectly inelastic collision. So definitions of perfectly inelastic collision indicate that during perfectly inelastic collision, two bodies they stick together and then they act as a single body and then they move with common velocity v. So during perfectly inelastic collision, two bodies after collision move as a single body with common velocity v. So in inelastic collision, kinetic energy of the body is lost or changes, but linear momentum, always conserved, always constant. So going to use these 2 points here. So let B have a body A who having a mass say m1, and let initially it is moving with initial velocity u1. There is another body who having a mass m2. Let V is that body, but it is at rest. It means its initial velocity is 0. Again now, let these two bodies collide with each other and the collision is perfectly inelastic collision. So in perfectly inelastic collision, these two bodies they stick together. So now the total mass of the body is now m1 plus m2, and then they move with common velocity v. So let v is here their common velocity. So this is the case of before collision, and this is the case of after collision. Now since there is a law of conservation of momentum, so law of conservation of momentum is valid. So now according to law of conservation of momentum, so total momentum before collision must be equal to total momentum after collision. So total momentum before collision of A and B body, that is m1 u1 plus m2 0 equal to m1 plus m2 v, or we can say that v equal to here m1 u1 upon m1 plus m2. Let first equation, since kinetic energy is not conserved, so let initial kinetic energy of A and B body before collision, that is initial kinetic energy equal to now, that is half m1 u1 square plus 0. Since second body is at rest, so its kinetic energy is 0. Likewise, final kinetic energy of A and B body, let it is represented as KF. F stand final kinetic energy, and it is equal to now half m1 plus m2 v square. Now loss of kinetic energy. So loss of kinetic energy equal to, that is initial kinetic energy minus final kinetic energy. So initial kinetic energy having a value that is half m1 u1 square, and final kinetic energy having value that is half m1 plus m2 v square. By substituting the value of v here from first equation, so v having a value that is m1 u1 upon m1 plus m2, substitute here in this equation, we get that is half m1 u1 square minus half m1 plus m2 v square. Now instead of v square, substitute this value, that is it is equal to, now that is m1 u1. Since square is there, so m1 square u1 square upon m1 plus m2 whole square. So just simplify it. So m1 plus m2 cancel by this m1 plus m2, and here in denominator we left m1 plus m2 only. Half m1 u1 square, it can be taken common. So half m1 u1 square can be taken common. So here we get 1 minus, and here we get, here m1 is left, rest is taken common, and other is m1 plus m2, which can be further written, that is half m1 u1 square. Take LCM, m1 plus m2 minus m1, m1 plus m2. Simplify it, we got that it is equal to now half m1 u1 square, and rest is m2 upon m1 plus m2, which can be further written, that is half m1 u1 square, it is initial kinetic energy. So initial kinetic energy, and rest is m2 upon m1 plus m2. So this is the expression for loss of kinetic energy. So during perfectly inelastic collision in one dimension, there is a loss of kinetic energy, and the lost kinetic energy equal to here, that is half m1 u1 square and m2 upon m1 plus m2. So remember this or revise this topic article, it's simple one. So just remember the definitions of this, that is perfectly inelastic collision indicates that if there are two bodies and then during collision these two bodies they stick together and then they move as a single body with a common velocity v here, like this way. Also in the definitions of inelastic collision, always remember that linear momentum of the bodies always conserved, but kinetic energy is not conserved, that is kinetic energy changes here. So here kinetic energy is lost in the form of heat or sound here. So revise this topic, it's important one and simple topic. Thank you.